Hello and welcome to this Unity tutorial. Today we will be building sort of an actual game this time. A lot of this stuff initially might be familiar to you. I've covered it in class already, but one of the good things about starting from scratch every time with a new project is that it allows you to really familiarize yourself with the fundamentals of the mechanics that are required to be produced for a game, rather than creating something and then expanding upon it, but never really understanding how it works in the first place. Today we'll be creating a 2.5D platformer, so I'm going to go ahead and create a new project. This time I'm going to choose it to be 3D. Let's call it like platformer or something like that. Oh, it already exists apparently. Platformer test, and then we're going to go ahead and initialize our Unity project. Now, as we wait for this Unity project to arrive, as it were, I'm going to talk about what it is we're going to do. So we're going to create our character to move around in this 2.5D perspective. We're going to be able to jump, and finally we're going to want some sort of fail state condition, and I'll show you how to do that with colliders. Here we've got our 3D environment that we're going to use. Now, what is 2.5D? You might have heard me talk about it before. It's really the middle ground between a 3D game and a 2D game. Now, obviously, with dimensions, there isn't really such thing as 2.5D. However, a 2.5D game is something that might be, for example, rendered in 3D, but the game mechanics play out in 2D, essentially. I'm going to go ahead and create a new 3D object cube. This can be our floor. Let me stretch it way out. Make it really thin. We're going to go ahead and create a material for the floor. And in our game, in this game, we're going to have the floor be that you die when you hit it. So we're going to call this something like lava. Let's make it an evil orange so the player knows they'll die. Well, that's not evil enough. Let's make it a bit redder. Okay. So now the player should know they'll die when they hit this floor. Then we're going to go ahead and create some platforms. Oh, I've stretched this out in the wrong direction. Let's stretch it out on this x-axis. Okay. Let's create some platforms. Thin, long, floating in the air. We're going to use Control D to duplicate that object, so we can duplicate our platforms, move them out, and create just a series of platforms along this x-axis here. And I can tell that it's the x-axis because whenever I move all objects along this axis, you can see the value of the x-axis of our position variable, vector3, is changing values as we move up and down this axis. So we've got our platforms. Let's go ahead and create our player. For this, we're going to use a cylinder. Drag this up, hover over one of our platforms. Looks a little bit too big to me, so I'm going to go ahead and change this scale from 1 to 0.8, maybe 0.7. Let's have a look. Still a bit too big, so let's go for 0.7. Though, you know, really we could change this to whatever we want. Okay, so we've got our platforms. One thing we can do is change the camera perspective. It's a bit low at the moment, so I'm going to raise it up, and that looks like a slightly better view for now. It will work fine. Let's go ahead and add a rigid body to our player cylinder. This will allow it to interact with physics. This might be a very familiar process for you by now. We're going to go ahead and type in rigid body. It's the first one. This time we're not using the 2D, we're just using the normal one that works in 3D. So whenever we run the game, our object should now fall and hit our platform. Let's go ahead and add our player movement. This time we're going to go ahead and add a component, but we're going to make our own one. I'm going to call this one player movement. And once it's created, we've added the component. I'm going to double click on it so that it opens in Visual Studio. So what do we need to do to move our object? Well, the first thing we're going to need to do is create our public rigid body. You can see it autocomplete here, so we don't have to type in the entire thing. We can just go ahead and press enter. Our rigid body variable, body, call this like player body maybe, and then the semicolon. Always got the semicolon at the end of our variable declarations. So we can go ahead and save that, Control S, and now our variable will appear. We can drag our rigid body in. All right, we're going to change our update method to fixed update, and that's because whenever we're making changes as the game plays out to our physics, the physics is actually updated not once per frame, but based on this fixed update method instead. It's sort of like running parallel to the rest of the game. So we're going to go ahead and add our if condition. If, and then in our brackets, we're going to add that condition, which is going to be input.get key. And then within the brackets of the get key, we're going to add the argument for that, which is a key code dot A. In this case, it's a capital A, but it's just A on our keyboard. That is the input rule that will trigger whatever is inside this if statement. And let's go ahead and create the same one for our D key. So this will be moving left and right. This may all be familiar to you, but we're going to go ahead and create our vector 3, which is going to be the left direction. This will be the direction that we use to move our character left. And we're going to copy paste that and make this a right direction. So one thing that we want to do here is create something that is a bit snappy in how it moves. So whenever we move left and right in our platformer, we don't want something that feels floaty, like it has acceleration and deceleration. Instead, we want something that feels instantaneous. So the player moves instantly the moment you press down the D key, and the character stops the moment that we let go of that key. And to do that, instead of using our .add force that we've used in a few other tutorials, we're going to just directly change the velocity of our character. And we can access the velocity of the character through the rigid body. So we're going to go ahead and say rigid body dot velocity is equal to our left direction on the A axis. And then we're going to copy this into our other if statement for the right direction. Let's go ahead and save that. The last thing we're going to want to do though is multiply this by time.fixed delta time. And that is because we don't want our object to move differently depending on the frame rate. And when we multiply it by the time that has expired between frames, we make sure that we're moving the more whenever the frame rate is less, and then we're multiplying it by a greater amount whenever the frame rate is very low, but whenever the frame rate is very high, we're multiplying it by a very low amount, and therefore the end result is no matter what your frame rate is, the character will move consistently at a consistent speed. Now we can't forget to actually change the values of our left direction in the Unity Inspector window. In this case, to go left, we're going to go -40. I'm not sure if this number will be great or too small. It's always just a case of experimenting and seeing how fast the object goes. Oh, it looks like it's falling over at the moment. We'll have to fix that, but that looks good to me. Let's go ahead and make sure that our character can't fall over. And this is where the 2.5D comes in as well, because we can, under this constraints in the rigid body component, we can constrain the rotation, right? So we don't want the object to rotate at all. We want our player to always be standing upright as it moves around. But we can also constrain its movement on other axes. So because it's a 2.5D game, we want it to move along this axis. Let's have a look and see what that one is. That is the x-axis that we're moving along. We'll also in the future want to jump and fall, which is the y-axis. But we don't want to move on the z-axis because that is the depth that we don't want in our 2.5D game. So I'm going to go ahead and freeze the z position also of the character. Though I should make sure to do that when it's in the correct position. Let's go ahead and run the game now. Alright, that looks good to me, and then whenever I move, I'm moving very slowly. One of the reasons that that might be the case is because of the friction that I'm getting between the object, which is the platform, and the player. Let's remove all friction because, again, we want that instantaneous, snappy movement by creating a physics material. Simply zero out these values for dynamic friction and static friction, and now we can apply that to our character in the physics material. Where is it? In our rigid body. Sorry, no, in our collider. Here it is, here. Physics material in our material. So we're going to drag that in. We're going to want to apply it to all the platforms. So I'm going to go ahead and shift select all of these cubes and drag in our physics material into our box colliders for them as well. So now we should have zero friction as we move our character along. Now, one thing that this does cause is that our character will continue to move left and continue to move right long after you've released either of those keys. And we'll want to eliminate this problem in the next video.